Hello, welcome to the conference, and thank you for being here. Today we're going to talk about subaqueous temperature regimes, and do we need them? Uh, I'm Matt Dorman, a GIS specialist and soil scientist in Connecticut, and I'm on the Coastal Zone focus team. So we'll first start off talk about why they're important. So plant species, seed germination, and soil fauna have temperature requirements for growth, survival, and soil formation. There are three methods that are typically used to define soil temperature regimes. The most practical and cost-effective is using the air temperature records to estimate the mean annual soil temperature. Studies have been done in the United States, and adding 1 to 3 degrees Celsius to the mean annual air temperature will provide an approximate mean annual soil temperature at a depth of 50 centimeters. And this relationship varies obviously with location and can have greater differences. The more accurate and costly method is ground truthing, going out and utilizing actual thermometers and sensors and getting that data from the field. And well-documented areas with field recorded soil temperatures, air temperatures are inferred from geographic location, so with elevation, aspect, and topography, and the relations between their natural vegetation. So those are used to determine, to tweak the soil temperature regimes within each soil survey office. Let's look at the factors that affect the mean annual soil and air temperature relation. When you look at the list here, these factors are going to do one of three things. It's either going to warm the soil, or it's going to cool the soil, or it's going to act like a buffer. Snow is going to act like an insulator. Groundwater is going to have less of an amplitude of temperature fluctuations. If you look at aspect, the south and west facing slopes are going to be warmer than your north and east facing slopes, which are going to be cooler. So I just wanted to cover these. I want to share three things in this slide. And first is the limit of the soil temperature regime classes, and that there's also 6 temperature regimes. And over here at the flow diagram, it shows the factors that we previously just learned about in the other slide, and how they affect the temperature requirements for it to qualify. In this one here would be for a cryotic soil, and the factors that we're talking about, for example, would be like groundwater and organic horizon. And last is we have these ISO classes. So the thing about these ISO classes is that there's less temperature fluctuations between the summer and winter, and because of that, they get their own class. Thanks. Our neighbors over in Rhode Island did some research by Salisbury and Stolt on estuarine subaqueous soil temperature. And they found that the soil temperature was primarily influenced by the water temperature and depth. And there was no method provided in estimating the subaqueous temperature at the time. And there was little variation in the sensor depth and or the submerged landscape. And the mean soil and water temperatures fell within 1 degree Celsius. They found it was an excellent method to estimate the subaqueous mean annual soil temperature, and that the texture actually affects the temperature. Sandy soils seem to be warmer than the coarse silty soils nearby, and the subaqueous temperature may be warmer than the actual tidal marsh temperatures. And they also mentioned the mesic regime may be outside of the intended extent. After reading the journal, I was curious to see how far the extent would go. So I went to my university's website and uh, searched for ocean water temperatures, and obviously I went to UMaine and I downloaded the temperatures for Eastern Maine and Penobscot, and after some calculations here determined that they were mesic. So we would have a mesic line going all the way down east. And I also downloaded from NOAA some temperatures, and the majority of them also were mesic except for one. And I'm sure that's got to do with some of those sensors not collecting data at different parts of the time of year, so it changes the average off a little bit. Now, if we have different regimes, what temperatures are important, what ecosystems are important. I read this other journal from the Federal Geographic Data Committee, and that they mentioned that temperature has a big impact on the functionality of the ecosystem, metabolism, growth, photosynthesis, and mobility of organisms. And generally, for every increase of 10 degrees Celsius, the microbial processes double, including decomposition, denitrification, and nitrogen fixation. And the marine organisms, they can also tolerate and live within certain temperature ranges that may only allow a few degrees, just like some plants. The temp of the water determines the solubility of gases such as O2 and pH. And here are just the different temperature limits. With a little digging, the USGS and Esri created this EMU spatial data, and with the help of oceanic scientists, they've got over 50 years of average temperature data, and as you can see, they've got 6 temperature classes consisting of 5 degrees Celsius increments. So what temperature breaks do you think are appropriate for the story that we're trying to tell? In addition, do we need a moisture regime for subaqueous soils? In the Keys to Soils taxonomy, a tidal marsh soil is considered to have a per aquic regime. And in soil taxonomy, second edition, it states that the per aquic moisture regime is used for understanding the genesis. So having a per aquic moisture regime would help distinguish using the water temperature to estimate the soil temperature, and I think that would help clear things up. So what changes should we consider? We need official method to estimate the subaqueous soil temperature, which doesn't involve using air temperature. Using water temperature seems at this time to have less factors affecting that soil temperature, and the soil texture and water depth seem to affect that mean annual soil temperature for aqueous soils as well. Maybe we should think about developing moisture regime for subaqueous soils. And spatially, we need to compare the water temperature using the current class breaks and overlay it with the EMU temperature classes. And right now, research and determine which of these classes work best for subaqueous soils. Here are my sources, and I thank you for your time, and please reach out. We love to collaborate here, and thank you very much.